Hi, today I'll talk about question 21, merging two sorted linked lists and returning the list as a new sorted list. So in the example, we are given an input which looks like this: 1 connected to 2, 4, and then null. And then the second part of the example is 1, 3, 4, and then null. The output should look like this: 1, 1, 2, 3, 4, 4, null, which is basically both of these lists merged and sorted. So how do we go about and solve this? Well, there are several ways we can solve this. One of the ways that I prefer is to first create a dummy node. After we create a dummy node, what we can do is we can iterate through both lists at the same time and compare them. So if one is bigger, if one is smaller or equal to, add it here. Otherwise, look into the next one. So let's look at this. Since it starts here with 1 and 1, it might be a bit confusing, but let's look at this for example. We're going to have a pointer that will iterate. So it will add this and this here first. But then if it comes here, it will see that 2 is smaller than 3. Therefore, it will add 2 as the next pointer. And then it will iterate again and see and compare 4 and 3. If 3 is smaller, then it will add 3. To imagine this, let's imagine there is a pointer here. And the first thing it will do, it will compare both of these values. And in this case, it will be the same. So this will ruin the diagram a little bit, but I will give a good explanation. So we're going to just say point to this one for now. And then if we have it over here, if we have a pointer here and here, so now that we pointed to this one, we're going to shift this to the other side and compare both of these values. Well, this one is smaller, so take this pointer and do it here and shift this to the next one. Compare both of these. Well, this is still smaller than this, so have a pointer here and now shift this to the other side. Well, this is smaller, so then take this pointer and have it back here. So you get the idea. We have one pointer shifting on every iteration, and then at the same time, we're comparing the value of both. So let's write this in code. Perhaps it will clear things out a little bit. Let's create an empty node, and that will be, let's call it dummy, and it will equal to list node 0. Or actually, let's do that as list node float minus infinity, which basically means this is infinitely small. Just in case these were all negative values, then the dummy node, this will ensure that the dummy node will always be the smallest value. And then we will create a pointer called priv, and it will point to dummy. So to illustrate this, we have essentially created an empty list node with the value minus infinity in here, so it's infinitely small, and we had a pointer called priv pointing at it, and that's it. There is yet nothing in the next connection. So what we can do is we can start now looping through both of these, and we can say while L1 and L2. In this case, L1 and L2 can refer to this here. So this is list 1 and this is list 2. So while list 1 and list 2 basically means while we have not exhausted the iterations on both of these lists. So let's say this here was 10 values and this here was 3 values. Then once you've exhausted the third list, then what you want to do at the end is simply append this list, the remaining of the values here, onto that one, because there will be no point to continue iterating on this because this is already a merged list, a sorted list, sorry. So what we're saying here, while L1 and L2, so while there are values on both, if L1.val, so if the value of L1 is smaller than the value of L2, then the priv.next which essentially is this one. So this here, the priv.next should point at L1. So what we're basically doing is pointing at here. So this will point at L1 if the value is smaller than the value of L2. So basically in our else statement, what we can do is priv.next equal L2. So whichever is smaller, if we had L1 here, and we had some sort of L2 here, whichever is smaller, point at it. So let's say in this case was this one, so simply point at that. And here is the preview flag, and now we know that the priv.next is this. So after this if or else statement, we want to write that your new priv will be the priv.next. So whatever this priv.next is pointing at, shift this new pointer to priv. So let's say it was this one. So now priv is here. Priv lies here. Now what about L1 next? And we basically want to, what about the rest of L1? Sorry. What we want to say is the rest of L1 is basically L1.next. So what we're doing is we're attaching the rest of the list here. So whatever L1 was, you continue doing it here. The same here, whatever the next of L2 was, you will continue attaching it here. Basically, what you want to do is you're just making sure that the smallest values are getting appended to this new dummy node that you have created. Now let's walk through let's continue walking through here. So if we come here, so let's go again to the beginning of the loop. And let's say if we give this value 1, and let's say the next one here is a big number, 10 or something, and this is 2. So let's do that, and this is 2. So obviously if L1.val is smaller, so that's not true. So then your priv.next, because the priv points here, you're saying that your priv.next will now be L2. So this is going to go down here, and your L2 will be L2 next. So the rest of your L2 will be L2 next. So whatever the L2 was pointing here, it will then continue attaching the rest of the list here. So basically you have the original connection that was here was gone, was severed, and now it's pointing to this one. Priv will equal priv.next. So you can see that your priv was here. What's your priv.next? It's this one. So this will be your new priv value. Now let's say that this was the end of your list, and let's say here it was null, and that was the end, and then the rest of the values were going on here. Then we actually want to exit this while loop and write if L1 is not none, then give me back the list L1, else L2. You see, the only time this while loop will exit is if one of these lists gets exhausted. So in this case, if the L2 got exhausted, then I would like you to attach L1 to everything on the priv.next. So in our case, the priv is here, priv.next is there. So let's say it was L1, then the priv.next will simply point to here, and everything that comes after, else attach L2. And what do we want to return? We actually want to return our original dummy node with a twist, which is .next. So I want you to return everything from this pointer onwards. And in this way, we can have a merge to sorted list. Thank you.